Hi guys, welcome to the beginning of chapter 4. Chapter 4 is all about our triangles and properties within them. So the first section, like all sections we do in geometry or chapters, is to learn a lot of vocab in this. So pay close attention because we don't want to miss those easy ones on the test that just relate to vocab. All right, so pause here, try number 1 and 2 by yourself, and then return back so we can start chapter 4. All right, number 1 is writing the equation of a line perpendicular. So the first thing you need to do is find the new slope. So the slope of the original line, this line here, is -5. So the slope perpendicular to that is 1/5. So all you need to know to write an equation of a line is a point and a slope, and then put it into point slope format. Number 2 is a little bit of a tricky one. Let's see if you got it. So I gave you guys a little hint. It says, look at the same side interior angles on the right of the transversal. What I was asking you to do is look at these two angles, the 2x and the 90 degrees here. We know that same side interior angles add up to 180, so that is the equation I wrote here in order to solve for x. Now that I know what x is equal to, then I can look at these two angles down here. Since this is a 90-degree angle, we can assume that this side is also a 90-degree angle because two angles add up to 180. So then I just made the equation 3y minus 2x equals 90 degrees. We know what x is equal to because we just solved for it. So plug in x or 45 for x, and then you solve to get y equals 60. So moving on to triangles, we're going to find two ways to classify triangles in this section. So the first way we're going to classify triangles is to classify them by their angle measures. So you have 4 options. The first one, most of you guys have heard of all these, maybe besides the second one. So the first one is an acute triangle. An acute triangle has 3 acute angles. An equiangular triangle has 3 congruent acute angles. And since a triangle adds up to 180 degrees on the inside, divide that by 3 equal angles. That means each of these angles will be 60 degrees. A right triangle has 1 right angle. And an obtuse triangle has 1 obtuse angle. So now knowing that, we're just going to classify each of these triangles. So you have a couple triangles and a big triangle inside that one. And just so you guys can see what these angles are, this 100 right here is for that angle. That's all really in the 80s, obviously like in here for A. All right, so now we're going to be able to solve. So for triangle BDC, so triangle BDC is this one, BDC, look at the angle measures. We have 100 degrees, we have 10, and then we have part of this 90 degrees. But all we need to know is that we have at least 1 obtuse angle. So this is going to be called an obtuse triangle. It just takes 1 obtuse angle to make it that way. Then you have triangle ABD. So ABD is this triangle here. So you have an 80-degree angle, a 20-degree angle, and then we also know that this angle, if you really zoom in, this angle right here next to the 100, that's going to also be 80 degrees because, again, we're on a straight line. So 180 makes 180. So all 3 of those angles, 80, 80, and 20, are acute. So this is an acute triangle. And then lastly, ACD is the big triangle, so this whole thing. So you have 80-degree angle, the 90-degree angle, and the 10-degree angle. So that makes it a right triangle. All right, next one, classify just one here. Classify FHG. FHG is this triangle here. So if you have 2 angles being 60 degrees, we can assume this is going to be 60 degrees. Also, this angle adds up to 90. This is 30, so this is also another reason that's 60 degrees. Since they're all the same angle measures, this is called an equiangular triangle. So now that you know how to classify triangles by their angles, now we're going to learn how to classify triangles by their side lengths. You're going to be asked to do both of these at some point. So there's only 3 options for this one. You have an equilateral triangle, which means all 3 sides are congruent. An isosceles triangle is where at least 2 sides are congruent. And then a scalene triangle means no sides are congruent. And what you need to know here is that all equilateral triangles are equiangular. So those are the same, they're interchangeable. So all equilateral, equiangular, all equiangular are equilateral. But it's not the case for any of the other classifying. So also what I want you guys to know is that when you look at a figure, you cannot assume segments are congruent by appearance. They must be marked as congruent. Like I don't want you to ever look at a triangle and say, well, those sides look congruent. Unless they have these tick marks on them, you cannot assume anything. So make sure you're always going by tick marks and not just a look. All right, this one, same idea as what we just did before, but now we're looking at the side lengths instead. So first one is triangle EHF. EHF is right here. So look at your tick marks. You have a 10 here and then a tick mark here. So that is going to be called an isosceles triangle because they are marked that way. Then you can have triangle EHG. EHG is the big triangle. So you look at the side lengths. You have 12, 11, add these two together, 14. None of them are the same. So this is a scalene triangle. And then lastly, you have HGF. HGF is this triangle on the right-hand side. Again, look at the side lengths. You have 10, 11, 4. None are the same, so it is another scalene triangle. Second problem on this, just one. So you have triangle ACD. So ACD, so this triangle on the right-hand side. So we have 18, 5. We're missing this side length on the left-hand side, but we know these are marked congruent, so I can assume this is 15. So, but they are all different. So since they're all different, then this is called a scalene triangle. All right, now on to math. Now that we can actually classify these triangles, you're going to learn one math property today. The first one you guys already know is the triangle sum theorem. We know that all angles inside a triangle add up to 180. That's going to be very prevalent in all the equations that you solve or set up to solve. So when in doubt, just add up 3 angles, set it to 180, and that's usually what the work you're going to have to do in this chapter. Another equation you're going to have to know is this one. This is called the exterior angle theorem. What this states is that this outside angle, so the one that's next to, it's on the same line as an interior angle. So 4 is equal to adding up the 2 remote angles. So the 2 angles it's not attached to. So you just add up the one it's not attached to, set it equal to the outside angle, and that is an equation you can use to solve for any of those angles. So for example here, the outside angle is x. It is equal to adding up the 2 remote angles it's not attached to. So x equals 31 plus 91, and you get 122 degrees. And now that we're solving for angles, always make sure it looks about, like we know that this angle looks like an obtuse angle, so it makes sense that the answer is an obtuse angle. Just always try to verify and logically see if your answers are making sense. All right, number 2, same idea, but the x is somewhere different, but doesn't matter, still the formula exists. So 142, the outside angle, is equal to adding up the 2 remote angles. So that's your equation. So 142 equals x plus 93. And then you just solve that, and you should get 49 as x. So what happens if you have a couple triangles? So don't get nervous here. There's actually a lot of different ways you can solve this. As long as you know a couple properties, obviously the exterior angle theorem. Also, we know that, for example, all angles in a triangle add up to 180. So there's a lot of different roundabout ways to go through this. I'll show you the easiest way I would approach this problem. So for this problem, I'd first note that this 40 is not one of those exterior angles like X is. So X is that exterior angle we've been concentrating on. 40 is here, though, to show us that you have vertical angles. So we actually know that this angle inside here is 40. What I'm now going to do is treat this big triangle as 1. So I'm going to look at this triangle as one whole one and not 2 together. So I have 40 degrees here. If I add up this angle, that's 85. Then I could do my exterior angle thing where I do X is equal to adding up 40 and 85. So I just like to look at it as one big triangle. And to me, that's the easiest way to solve this. Like I said, there are different ways to solve this. You could have solved, for example, like each individual triangle. So you could have found, like, looking at this triangle, you could have found this angle, subtract it from 180 to find this angle, right? You could have just keep on solving, but this would be the quickest way to solve that equation. So pause here, try the next one all by yourself, and then return back for your answer. All right, number 4, you should get 93. You should have used the vertical angle theorem again to set up your equation. All right, let's go through a couple more of these. I'm going to go through a little bit harder ones. So same idea here as that I went over in number 3 with you. So use the vertical angles theorem. So this should be 35. Again, I would highly suggest the easiest approach would be to look at this as one huge angle in order to write your equation. So this is 35. This is going to be 37 plus X. And we're going to add these together and set it equal to 114. So 114 is equal to adding the remote angles together. Happens to be 3 here, but it still works out. And if you solved all of that, you're going to get 42. Again, the purpose of these notes is always to set up the equations. It's not to show you the algebra. If you're struggling with the algebra, please come and see me. But I'm mostly showing you guys how to set up these equations. All right, let's see if I can throw in a little bit of a harder one for you. So what we have here is obviously now we're going from just numbers to expressions, but the same idea still exists. You have your outside angle 48. You want to add up the remote angles together. So let's add up those remote angles. So 3y plus 1 plus 2y plus 2 equals 48. So exactly the same setup. You just have expressions now and just a little bit more solving to deal with. So you're going to have combined like terms. So you get 5y equals 45. And you get 9 as your answer. You get 9 as your answer for y, but as always, you want to make sure we answer the question. It said find angle M. So we're going to plug it back into M. So 3 times 9 plus 1. So 27 plus 1. So that angle is 28 degrees. All right, going back to chapter 2 with some of these properties, what this states here is L is parallel to M. So L parallel to M, if it was spaced out a little bit better, that's what it should say. Because showing parallel lines, you're going to now have to think about your special angles, like alternate interior, same side interior. Those type of things might help you in these problems. And as I'll be showing you here, number 6, there's a lot of different ways you can solve number 6. I'm going to try to show you the quickest way, but there are, knowing that a triangle adds up to 180, there are plenty of different ways to solve for X here. So I'll show you one way. One way I would do it is this. So we know, for example, these lines are parallel, the L and the M. If this is my transversal here, I actually have alternate interior angles that I can see. So for example, I see that X is an alternate interior angle with this angle. So those are the same length, or size, I should say. Now I should see that these three angles sit on a straight line. We know that a straight line from chapter 1 adds up to 180. So that could be an equation. So I can say x plus 72 plus 59 equals 180 and solve for x. That completely works. Or maybe you saw this. Maybe you saw this happen. So let's erase that. Again, these are parallel lines. So what if I looked at this transversal and these parallel lines? If I treated this as one angle together, so basically ignore this line in between. So treated that as one angle together, and this angle, these are same side interior angles. What do we know about same side interior angles? They add up to 180. So it'd be the same idea there where you do x plus 72 plus 59 equals 180. So you see how they actually are the exact same equation. I just got to it in a different route. So whichever way you need to approach it, but just make sure you're using your special angles in order to get there. And then once you solve, you should get 49. A third way you could have easily seen this also is this, before I let you move on to the next one. You could have seen that 59 is interior angles with this 59, and we know our triangle adds up to 180, which again would be this same equation. So try number 7 all by yourself and then return back for your answer. All right, again, several approaches to this problem. The approach I did was the exterior angle theorem that we've been practicing in the beginning of these notes. So I did 120. So first I saw that 35 and 35 are alternate interior. Then I know that an exterior angle is equal to adding up the inside angles, and that's the equation I decided to use to find x is equal to 88. Another way I could have possibly found this is that knowing that this is 35 and this is x, all three of these angles add up to 180 because it's a triangle, and I could have found this angle by subtracting from 180 because it's a straight line. So again, multiple different ways to solve these. Just make sure you know these theorems, and if you know all the theorems, there's obviously multiple alternate routes to get the same answer. All right, couple more problems. So now let's get into solving equations or solving equations with expressions. So now we have expressions for angles, so just getting a little bit harder, but the same thing we've been doing all notes. So what we're going to do is find the degree of each angle. What we should do is just add up all three angles, set it equal to 180. So 90 plus 3x plus 24 plus 4x plus 10 equals 180. So that's all you want to be doing in these problems, is just setting all three angles to 180. You would solve, so you get 7x plus 34 equals 90. And you should get x is 8. And again, we're answering the question, so all you have to do is plug in 8 to your angles for your final answer. If you did it correctly, you would get 48 for angle L, and you would get 42 for angle K. All right, number 2, same idea. All three angles add up to 180. As you can see, we're going to use that type of equation a ton in this chapter. So figuring out how to solve an equation shouldn't be too difficult, or how to set up an equation shouldn't be too difficult, since we're dealing primarily with triangles in this entire chapter. So you should get x equals 21. And then again, all you have to do to find the final answer is just plug this into your expressions. So I should get 63 for L. I should get 28 for J. And I should get 89 for K. Lastly, we're going to deal with solving triangles that are isosceles. So remember, isosceles triangles have two angles that are the same. What you need to also note, which is going to be an important part of this chapter, is if we have an isosceles triangle, not only do you have two sides the same, you actually have two angles the same. And what specific angles are those? They're the ones across from these marked sides. So across from that angle or side is this angle. Across from this side is this angle. So both of these angles are congruent to each other, which is going to be a huge part in solving these problems. So if two sides are the same, that means two angles are the same, and particularly they're the ones across. So make sure it's correctly drawn for you. So not this one up here. All right, so we're going to use that property in order to solve this problem. As you can see, there's two isosceles triangles here, and just like the rest of the problems we've been doing, multiple ways to do this, so not exactly the way I might show you. If you see a little bit differently, as long as you're getting the right answer, I don't care how you set it up. But here's how I'm going to do it. I'm going to solve the triangle that doesn't have the X in it first, because obviously they brought this in for a reason. So let's solve that triangle. Well, we know that this triangle is an isosceles triangle. It has two sides that are marked. So we know the two sides angles across from it are congruent. So if this is 70, that has to make this angle over here 70 degrees. I know that a triangle adds up to 180 degrees. And so right now, these together is 140. So then this missing angle has to be 40 degrees to add up to 180. And now that I know that this is a right angle, that has to add up to 90. So this is 50 degrees. See how we're just like working backwards or kind of just solving the puzzle. Now we've moved into the second isosceles triangle. This isosceles triangle has these two sides marked, which means the angles across from them are the same. So if this one's X, that has to make the other one also X. And that gives me enough information to write an equation to solve for the sides. So now you have X plus 50 equals 180. So now you get 2X equals 130. So you get X equals 65. All right, number 2. So again, same idea. My hint would be they're giving you two triangles for a reason. So try to solve the one that doesn't have X in it first, because that will help you solve for X. Because right now we don't have enough information to solve for X. So you have to solve the first triangle first. So again, two isosceles triangles. We know that if this is 68, we know the other one is also 68. So this angle over here is also 68, which gives me enough information to solve for this angle. So we're going to add all three together. So we're going to do 180, or 180 minus 68, and you should get 44. And again, because we see a right angle here, that needs to add up to 90. So its neighbor is going to be 46. And then we're at our another isosceles triangle. So across from this side is X, which means across from this side is also X. And then we have enough information to set up our equation. So you have X plus 46 equals 180 degrees for the triangle. So 2X equals 134, and you should get 67 degrees for each of those X angles. So pause here and try the last one all by yourself. All right, you should get 22 in order to satisfy this isosceles triangle. So the only thing I had to do here was just find that this is 136 because 180 minus 44 is 136, and that gave me enough information to set up my equation. All right, so that is section 4.1 and 4.2. Get ready to do your ALEKS topics.